Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem exit point in a matrix. Previously, this problem has been asked in companies like Samsung as well. So let us read the problem statement, let us understand it and see how we can implement it. So the problem says that we'll be given a matrix which will be of n cross m size and it will be consisting of zeros and ones. So you can enter inside the matrix from 0, 0 in the left to right direction. So initially when you enter inside the 0, 0 matrix, so your direction is from left to right. So your direction is like this. In this direction you are moving initially. So initially your momentum is towards the right side basically. Then whenever you encounter a 0, you retain in the same direction. Okay. So what happens is whenever you encounter a 0, so you are in the same direction. Suppose if you were moving in the right direction and you see a cell that has the value as 0, then in that case you will still be moving in the right direction. Suppose that you were moving in the downward direction and now the cell that you have reached, it is having the value as 0, so still you will keep on moving in the downward direction. Suppose if you were moving in the left direction and the cell that you have currently visited, it is also having value as 0, so you'll continue in the left direction. Suppose that you were moving in the upward direction and the cell that you have reached right now, it is having value as 0, so you'll keep on moving in the upward direction only. But if you move to a cell which is having value as 1, so if the cell that you have reached, if it is having the value as 1, then you have to change the direction to the right of your current direction. Okay, so basically this is the main thing, change the direction. Okay, whenever you reach a cell, suppose that whenever you reach a cell, let's say mat of ij whose value is equal to 1, then in that case you have to change the direction. Okay, then you have to change your direction to the right of the current cell, to the right of the current direction. Now what does this mean, that you have to change your direction to the right of the current direction? So suppose that if you were moving on the right side, okay, currently suppose that you were moving on the right side. If you were moving on the right side, so you can assume that you will be standing here. Now this will be left for you and this will be right for you. So when you are moving in the right direction, what is the right of right? It is basically downwards. Okay, so you can say that if you were moving in the right direction and you encounter a cell with the value as 1, then you will start moving in the down direction. Okay, in the downward phase. Otherwise, suppose that if you were moving where? If you were moving in the downward direction. Suppose you were moving downwards, right? Then if you are standing here, so this will be your right and this will be your left. Assuming that you are standing here and this is your head, right? So this will be your left hand, this will be your right hand. If you are moving downwards, then you have to move on the right side of down. If you encounter a cell with the value as 1. So what is the right direction of down? Right of down is nothing but left. So if you are moving in the down direction and you encounter a cell with the value as 1, then you will start moving where? Then you will start moving on the left direction. Okay, suppose that if you were doing what? If you are moving in the left direction. Okay, suppose you were already moving in the left direction, then if you are standing here, so this is your left and this is the right. So what is the left of right? This direction. It is nothing but up. So if you are moving in the leftward direction, now you will start moving in the upward direction. Okay, suppose if you are moving in the upward direction, then what will happen? If you are moving upwards, so this will be your left, this will be the right. So what is the right of upward direction? It is basically right itself. Okay, so you can understand one thing very clearly, that if we were moving in the right side, okay, so we'll start moving where? We'll start moving on the down side. Okay, if we were moving in the right side, we'll start moving in the down side. If we were moving downwards, then we'll start moving leftwards. Okay, and if we were moving leftwards, then in that case, if we encounter a cell with the value as 1, then we'll start moving upwards. Okay, and if we were moving upwards, then we'll start moving in the rightward direction. Okay, so this is what we will be doing. I hope that you are getting my point here. Okay, so basically you can understand one thing, that if my current direction was right, so next time it will be down if I encounter a cell with the value as 1. If my direction was down, so next time my direction would be right if I encounter a cell with the value as 1. If my direction was left and I meet a cell with the value as 1, so my direction will become upwards. If my direction was upwards and I meet a cell with the value as 1, so my direction would be rightwards. I hope that you have got this very clear, right? Now you have to identify that what is your exit point. The moment you go out of the grid, okay, so that will be considered as the exit point. So you have to basically tell that from which cell you are going outside, that you have to just store in a pair and then you can return it. Okay, so this is the main thing. Now where you are starting from? You are initially starting from 0, 0. Now how can we change our direction? So like, let's talk about one more thing here, that what changes happen to your x and y coordinates if you are moving in any of the directions. Suppose, so if your current cell is x, y, if you are moving, let's say, on the right side, So if you're moving on the right side, so your row remains the same, column increases by 1. So that is nothing but x comma y plus 1. Okay, so you can say that when you're moving on the right side now, then change in x is 0, change in y is 1. Okay, then after that, if you're moving where, if you're moving on the downside, then what happens? Your row increases by 1, your column remains the same. So that will be nothing but x plus 1 comma y. Okay, so basically x will increase by 1, y will remain the same. If you're moving in the leftward direction, then what will happen? X comma y minus 1. Like x coordinate would remain the same and y would decrease. Okay, then after that, if you are doing what? If you are moving in the upward direction. If you are moving in the upward direction, then what will happen? Your x value that is there, it will decrease by 1 because your row will decrease by 1 and your column will remain the same. So that this will be nothing but minus 1 comma 0. Okay, and then again right, you can understand. So basically you can see here that initially I can do what? I can store these direction pair, because this is the small change in x, this is the small change in y. If I'm moving in the rightward direction, then 1 comma 0 is the small change in the x and y respectively if I'm moving downwards. So I can say that if I store these pairs 0, 1, 2, 3, 4 in like 2, 3 in terms of indexing, so I can say that initially I can keep my direction as what? 0. Okay, then after that, suppose if my direction is 0, it indicates right. Okay, then after that, when I'll increase the direction by 1, then I'll be moving in the downward direction. So suppose that if I was moving right and I encounter a cell with the value as 1, then what I will do? I will increase my direction variable by 1, and then this will indicate that I'm moving in the downward direction. So that is how I will change my coordinates. Okay, then after that, if I'm moving in the leftward direction, so my direction will, what will happen to my direction? Now my direction variable will become nothing but 2 here. Okay, and then like my direction variable will become 2 here, and then I'll start moving in the left direction. Okay, then if my direction variable is what? If it is 3, then I'll start moving in the upward direction. So I can access the small change in the x and y. Now after that, from upwards, if I'm going on the right side, so that will be nothing but like from upwards, if I'm changing my direction, so direction value will become 4. But I only have got indexing 0, 1, 2 and 3. Okay, so I can always do modulo with 4 for the rest of the part, because when my direction is 5, so 5 mod 4 will be what? 1. So that would indicate that I'm moving in the downward direction. This is how I can keep a track of the direction, and based on the direction, I can change my x and y accordingly, according to the pair, that is 0, 1, 1, 0, 0, minus 1 or minus 1, 0, right? So let's now try and implement this code, because this is the main basic stuff that we have to identify, that how we can change, or how we can always move to the right of the current direction. And if we are doing that, so how by making a small change we can easily do it. Okay, first of all, code this up. So first of all, we'll be having what? First of all, we need the rows and the columns. So we can say that int n is equal to what? Let's say matrix dot size. Then after that, what will happen? Int m is equal to what? Matrix of 0 dot size here. Okay, so first of all, I'll get the number of rows and the number of columns. Then after that, I want to store what? I want to store the answer. That is, I want to store the exit point, right? So that is why I'm having answer of 2 size, because it will help me to store the final coordinates, exit points. Then after that, I can say that initially my k value is what? K value is basically the matrix, current matrix value. So I can say that initially I can mark it as mat of 0, 0, because this is my starting point. Okay, and I will keep on checking whatever is the k value. If it is 0, I will keep on moving in the same direction. If it is 1, then I'll change my direction. Okay, so this is why I'm passing it. Then after that, I can call a recursive function, suppose, and when I'm calling this recursive function, so initially I can start from the cell 0, 0, then I can pass k, then I will pass n, m, and I'll also pass the matrix here. And let's say I'll also pass the answer array. And at the end of the day, when my exit points are updated, so I'll directly return my exit points here. Then after this, what we will be doing here is, like we'll build this function. So let's say we'll build void recursive function where we'll have int I comma int j. Then after that, we'll have int n comma int m comma what? Vector of vector int ampersand matrix here. Then after that, what we'll have is we will have vector int answer also, because we want to update it. Okay, now when this happens, so whenever we are at a particular cell, suppose, so whenever we are at a particular cell, then we have to identify that if we are going outside the grid, or if it is a normal cell, then whether the value is 0 or 1. Okay, so what will happen here is, whenever we are at a particular cell, so we'll say that currently we are at the cell ij, right? Or let's say we are at the cell x comma y. Okay, suppose that we are currently at the cell x comma y here. So I can do what? First of all, I can declare a pair array. Let's say vector of pair. Why we are declaring this pair? Because I want to store what will be the small change in the x coordinates, y coordinates if I'm moving right, if I'm moving down, if I'm moving upwards or leftwards. Okay, so what I will do is I'll declare a vector of pair, let's say direction. Okay, and then initially the first pair is what? If I'm moving on the right side, so it is nothing but 0, 1. Then after that, the next direction that I should follow up is what? The next direction is downward direction, so that will be 1, 0. Then after this, the next direction is what? Next direction is leftward, so that will be 0, -1. And then lastly, the direction is upward, so -1, 0 here. Okay, now after this, what I will do here is I will check the small change in x. The new x coordinate will be what? The current x coordinate that I am at plus what? Plus the direction of k dot first. Okay, because the first pair is changing, the small change in x, and k indicates what? K indicates the direction. So if my direction is 0, okay, if my direction suppose is 0, if my direction is 0, it indicates that I'm moving on the right side. If my direction is 1, then it indicates that I'm moving on the downward side. If my direction is what? 2, so it indicates that I'm moving leftwards. If my direction is 3, it indicates that I'm moving upwards. So whichever direction I am currently at, right, based on this k, I will basically get the corresponding change in the x, and then after that the corresponding change in the y as well. So the new y will be what? Existing y plus the direction of k dot second. So this is how I'll get the change. Okay, now after that I will check. What I will check is, like, after this is done, so I can say that this particular matrix has been visited. Okay, so I'll mark this matrix as what? I'll mark this particular cell x, y as visited. So I'll mark it as 0. Then once this is done, so I will check that if we are going outside the grid. So suppose that new x coordinate is less than 0, or the new y coordinate that I have got, it is less than 0, or the new x coordinate that I have got, it is greater or equal to n, or let's say it's equal to n basically, or the new y coordinate if it's equal to m. So if I'm going outside the grid, so this is my exit place, right? So this is like new x and the new y are going outside the grid. So if they are going outside the grid, so the last exit point would be x, y cell. Okay, so last exit point will be what? X, y cell. So in that case, what I can do is I can update answer of 0 as what? X. Then I can update answer of 1 as what? Y. And then after that I can simply return from here, because I've stored my exit point, because x and y are the cells which are the last valid cell where I am at, and after that I'm going outside the grid. Okay, so that is why we are storing those x and y cells. That is what is required in the question. Now once that is done, so after that what we will do is we'll find our change in k. So change in k will be what? Like whatever is the k value right now, okay, plus the matrix of, let's say, new x and the new y. So it will be nothing but the new x and the new y. Whichever new cell I'm going to, whatever value it has, if it has the value as 1, so my direction will get updated by 1, and I will do what? I will do modulo with 4. Why I will do modulo with 4? Because if the direction value becomes 5, 6, 7, so whenever I do modulo with 4, so I'll get the answers between 0 to 3. Okay, then after this particular part will be done, then I can directly call my recursion. So I can say that I will call the recursion for the new x coordinate and the new y coordinate. Okay, then after that we'll pass the k value, like n value, then m value, then after that we will also pass, okay, so I've not passed k here, just give me a second. So yeah, let's pass k here as well. Okay, then after this we'll pass the k value here. Then after k, what we are going to do is I should pass n and m here. Let's remove this. Yeah, so let's pass n and m here. Then after that we'll pass the matrix, and then after that we'll pass what? We'll pass the answer here. Okay, and once this is done, so we can simply say that our code is done. Okay, so let's now try and compile this to check if it is working fine or not. Okay, so right now our output is not correct, so this means there is some issue with my code somewhere. Okay, because it is not working fine on the sample. So let's see what I have done. Basically, first of all, I have stored the matrix size n and m, right? Then after that we are having the answer array of 2, 0. Then you can say that initially k indicates the direction basically. So initially my direction is 0. Let's do one thing. Let's take direction variable, or let's take k only, that's fine. Right, so let's take k only here. So initially our direction will be whatever is the matrix of 0, 0. Then we are starting from 0, 0 cell. Then we are passing k, n, m, then matrix, and then answer. And at the end of the day, we are going to return this answer. Now what we have done here is I will be making this pair. So when I'm making this pair, so initially what I'll do is I'll have the coordinate 0 0, then 1 0, then 0 comma minus 1, and then minus 1 comma 0. That is fine. Then after that we have the current xl, y, and then k, and then nm, and then after that we'll have the matrix, as well as we'll have the answer array updated, right? So then after that the new x coordinate will be what? The new x coordinate will be the current x coordinate plus the change the direction of k dot first. Okay, that will tell me what is the new x coordinate, and then after that the new y coordinate. And once I have got that, so whatever cell currently I'm at, I'll mark it as 0, indicating that it has been used so far. Okay, then after that I will check that if this particular cell is not valid. So suppose if the new x and the new y coordinates that I've got, if they are asking me to go outside the grid, so if the new x is less than 0 or the new y is less than 0, or what happens, the new x is equal to n or the new y is equal to m, then I'll simply store the x and the y coordinates, that those will be my exit points from the grid. Otherwise, if that is not so, then my change in k, yeah, so I'm not passing the change in k here. So I should say that if I'm passing k, so I should not write dk. Yeah, so now you can say that the k will be what? K will be the existing value, existing direction, plus whether the value of the matrix is 0 or 1 modulo with 4. So I should pass k here. That is what I was missing. So now I have understood this mistake. So let's try and compile it. Now it should work fine on the sample. Okay, so it says that k is declared again. Yeah, I don't need to declare it again. Now let's try and run it again to check if it is working fine or not. It should. So you can see it is working fine on the samples and we are getting the correct exit point. Now let us try and submit this code to check if our code gets accepted or not. So you can clearly see that our code is able to pass all the test cases, and I hope that you have understood this particular problem clearly. In case if you have any doubts, please make sure to mention them in the comments, and thank you for watching this video, guys. Keep coding.